Welcome to my Lab 2 projectile motion video report. My name is Anna Ndozo. The purpose behind this lab is to observe projectile motion. My group chose to use a stress ball and throw it at our table. Using the video, we're going to try and observe how the position of a projectile will be affected by gravity and also the effects of drag. We'll be using an experimental model and tracker and the computational model made by GLOWSCRIPT. Here are some fundamental principal equations I'll be using today. We'll be using the velocity update and the position update for the ball in motion, good old gravity, since that will be one of the main force acting on the ball, and F-net and Newton's second law, because that will be pretty important to try and figure out what drag is, and then also the drag equation.
Lab procedure. Capture a video of the projectile motion, put it into the track, use the data in GLOWSCRIPT, and then add drag force to manipulate the code to match the actual compare.
I don't know why my voice got so deep. Anyways, here's the video of the experiment. Wow! Here's the GLOWSCRIPT code. Note that under lines 62 to 64, there's the reference for B as drag. Since we haven't calculated it yet, we're going to be comparing this code and what it outputs with the actual results of the tracker to be able to see what the actual effects of drag look like on the model. Note that in 75 to about lines 91, it shows that the net force includes drag, but since we don't have anything for drag, it won't be affecting the model. Taking the data from the video and the table from the tracker app, I was able to get the initial velocity around negative 1.8 meters per second in the x direction and 1.13 in the y direction, and for final, negative 2.48 and negative 0.07 for x and y respectively. All right, notice anything? The top models are pretty similar with how the ball's motion was tracked. However, since the ball was thrown from the right and not the left, the velocity in the x direction was negative. For the sake of graphs and also consistency, I flipped the x direction to being positive for future velocities. So do keep that in mind whenever I'm looking at future graphs. And if there's any inconsistencies, you may notice because it's not negative, it's now positive. It doesn't affect anything besides just the numbers being positive rather than negative. Before in the previous model in the code, it had a severe lack of drag. I can't keep getting away with this. So, to remedy the fact that we didn't know what drag was, I decided to use Newton's second law and the change in momentum over time equal to the total force acting on a system to try and reverse engineer or figure out what drag is. Remember on the fundamental slides, I showed the equation for drag, but I also showed the force of gravity, which is negative mg in the y direction. By taking that force and the change in x and y's velocities over time and accounting for gravity, I was able to conclude that the drag is 0.61. And after inputting it, you can see that the position over time curves because there was some lack and loss of momentum due to drag. Now, here's that part of the video where I'm supposed to ask what ifs. Now, some things didn't perfectly line up. Some of my measurements weren't exact, and some of my numbers got rounded. This led to possible errors. And what caused those errors? Me. I'm human, and also the software is only as perfect as my guesstimation of where the ball and its motion was between frames. I can admit that between frames, sometimes the ball's image was blurry, so I kind of had to guesstimate where it actually was. And also doing the math, I started to round numbers, which could have led to some issues somewhere down the line, where I might be a couple decimal places off or a little bit off from the exact true answer. And also the act of outside forces. Sure, I'm trying to calculate only drag, but the room was not airless. I couldn't guarantee there wasn't a breeze from a passing by student, nor could I guarantee my groupmate when he was throwing the ball had a perfect throw. All these things combined could also lead to the reason why possibly some of my calculations might be off, the video might be off, and also my final answer. But that's to be expected. This is a student experiment. Thanks.